So, and I just want to thank Chris and Jaspreet for their last talk, and similar to how Sean and you were discussing, the reference design process actually has, for the next phase, the necessary feature in the reference design that we call generalized access architecture, which is so that the access architecture allows and actually can identify how it extends to things. And you've done a very good job at showing how you would go through the process for an actual example. So whenever you're ready to contribute to a reference design for cable access, we will be interested in also to discuss how do we represent it correctly for generalized access. My talk is actually a little bit on a different dimension, and my background includes deploying network elements and EMSs and management as a vendor, and then working in AT&T UVerse across multiple operation systems, and now in access for thinking about doing such with SDN, with virtualization of the network elements, with open source. And so the assembly of the parts is different. And since we have 15 million broadband subscribers using a variety of EMSs in AT&T, we have some experience in what their pain points are. But the other aspect of it is the discussion at any scale, we actually are experiencing now within AT&T as well. We know we don't have a full stack that we went and certified with operations and actually developed so that we could deploy it at large scale. But we deployed SEBA as a virtualized network element essentially in 2 locations, and the operators directly access into SEBA. So we've also met some operators, including at ONS this year, who have an interest in starting small and maybe even existing small with SEBA. So I think there's some benefit in the community to discuss how do we make those operators successful as well. It'll help with the supplier community as well to be interested in supporting any operator view. So I want to start with a base model, and then you'll see why I step from this slide into other cases. And so this is not specific about how we're doing the internals of SEBA. It's more about how do you fit it in with the overall picture. I think there are other presentations that do that as well, but we break this down in a certain way because of some other open source projects than SEBA as well, and you'll see that as we work through the slides. So one thing is, whatever you call it, when you go and install your rack of servers in your CO, you're creating a SEBA Edge cloud, and you do an infrastructure orchestration day 0. So everything's done when you're done with that, similar to what Tina talked about, and at the end of the Akraino, the ARM presentation that talked about Akraino use cases, but you don't have to use Akraino. If you were at small scale, I could do it at small scale. Maybe Akraino will help, but that's what you have to do. Then the next step is I've done that, and starting at day 1 and then plus, I deploy and upgrade the SEBA software, and then at that point I put in my access devices, and I set them up to be ready to configure services. And so a little bit on the generalization is we're looking for the right terms. These may not be the right ones, but that's a generic access network, maybe different names. The ASG in the reference design is a functional view of something like could include the BNG, but in this case, the BNG isn't external. It's the layer 2 and 3 gateway, and that's important to understand when we go to the next slide. So what happens At the BNG is, this is layer 3 over here. So what that means is wherever, now we're talking about new services in the network, our fun things like AR, VR, AI, machine learning. We'll put them on an app cloud. That can be anywhere in the layer 3 network. That's the point there. So, and we know about OSS and BSS, external BNG management as well. And then we can go to the next slide, say, what are we going to change on the next slide? On the next slide, we are going to converge the BNG. So the BNG becomes part of the ASG function. It's running inside of the pod, so to speak. And now we're converting to layer 3 here. What does that mean? Well, I don't have to go to the metro network to go further out to a higher latency to get to applications that are OK at that latency. I can run applications that use a lower latency, really where SEBA is, essentially, in the CO, let's say, for example. Those can be smaller. Those can be more purpose-built. It gives flexibility for those types of things. So it's a different dimension for applications. So this is really a view of applications at a different scale. The ability to be flexible on where they're located can let you scale in a different way for your lower latency and your higher latency applications. So now, depending upon the workloads, the clouds are separate, edge and SEBA, but perhaps they have a similar way of using compute. So maybe they can converge and share some resources, but that would be an engineering question for how the apps work and how SEBA evolves as well in different implementations. Okay, so that's a dimension of where the BNG can change things. So let's just focus now. We'll keep the same picture basically, but let's talk about small scale. So maybe I'm a large scale operator, and I want to start this way because I want to prove out my virtualized network element. That's a position familiar with now. And let's say I know I'm never going to go beyond a few SEBA sites, and you have to think in terms of the workforce here and how you operate things. So if you're a small operator, maybe you don't have as many services. Your service creation model is simplified. Maybe everyone gets the same service or a small number of the same services. And in some of those environments, some of those operators use the EMS of a vendor like an OSS almost, or because at that scale, you can use a few techs to set up the infrastructure at the beginning and even the workload, and then they can log in essentially to the SEBA nodes. And the OSS could be simplified or optional. You may still have some OSS, BSS, but if you simplify your service management model and such, I've seen very simple things done in tier 2 and 3 operators in an access use case. So what that does is you're not as heavy and you're not as constrained to get started. As soon as you have a stable functional, what you want from the functions of SEBA, you could be very close to getting started and providing your services. And then you're solving other problems at that point. So this is just a typical list of the OSS operations. So if you can address the security within SEBA, let's say, of users logging into SEBA, all the authentication and authorization there, it's a layer you build into it. And I want to say something here. So talking to ONF, and when you look at the demos for SEBA that you see in the hall, you'll see some GUIs or that have the ability to really configure the services. You can see the ONUs come up and so forth. maybe a little bit more work to customize like the security around that and so forth. But they were using XOS as a driver for that. And then in the Sterlite booth, they also took the CLIs of some of the different functions, and they created a consolidated CLI. So there's different things that you can do with your creativity to take it to how you could essentially minimize the OSS and directly do some actually operations at the SEBA level. So there's more to the software architecture of SEBA that allows that, that could be explored further, but just wanted to give a flavor of that. And then, of course, we'll flip to large scale on the next slide. So the picture, again, looks the same. We're not changing the picture. We're changing what we're going to say about the picture. We need a large number of SEBA edge clouds. It may be very geographically distributed, and we may be serving a lot of customers even in each region. We automate these functions in OSS and domain management because of the scale of the workforce. All the remote techs, the essentially data center techs and operations management, and then even workforce that gets out into the network, and anything that helps solve the problems remotely and with less operators is good. Now this is now we actually added for automating the infrastructure orchestration. Let's say we're going to use Akraino, because we're going to do thousands of these like we've heard. So that is for the same purpose, optimizing the workforce, right? So you have a template, you're going to repeat it. And then very similarly for workload orchestration, I have SEBA 2.0 next year with Volta 2.x. I do my first deployments, and then we're going to do an upgrade to SEBA 2.x and Volta 3.0, and I need to push it out to the first 50 or 100 sites that I'm at, and then I need to get better and do 500 and then 1,000 later on. So that is there's an aspect there. Could use ONAP, which we'll talk about on another slide, and so that the OSS layer and the ONAP layer, where some of the OSS functions port over to ONAP, and then you have some of your traditional OSS functions that stay the same. You have this. You work towards the automation for scale across your many nodes and many subscribers. So this is to address some of the other open community references and what they are and what they're doing. So very related to a talk from ARM earlier today about including about Akraino. The SEBA for Akraino Telco Appliance Blueprint family, which also includes a radio edge cloud, has reusable components from its Blueprint family. The continuous deployment aspect is for the Akraino development as that software continues to develop. Testing on multiple hardware platforms, and this is related to the multiple architectures of compute, so that ongoing qualification deployment of servers that are optimized, new models of servers for improved cost and space, power, and environment. And in OCP, that is related to this point here of options for the servers, taking some of the different options to OCP, creating a reference design there, and then where multiple vendors create designs. So in Akraino, there's a concept of an Akraino regional controller, which is an Akraino project, which gets orthogonally deployed out into the network so that it can be a workhorse for that automated blueprint deployment, not just to SEBA, but to other types of clouds. Okay, so this picture here is about some work that happens in ONAP that there are contributors from multiple operators and vendors, including within AT&T. And what is SEBA built upon? It's built upon a Kubernetes workload with a Helm chart. So it can reuse an effort in ONAP, which is a multi-cloud service project, and already addresses and has its own roadmap for supporting different cloud types. And it actually references in the ability to address some of the common, well-known clouds that have a Kubernetes service as well, so that those could be used for other things. If you wanted to host SEBA in the cloud and operationalize it that way, it's not drawn that way here, but this is, you have a common Kubernetes framework, essentially could run in those environments. You have to think about how you connect to your devices that way, but it's possible. And of course, on the right is SEBA with also in that, this shows the Edge App Cloud integrated into it, sharing some compute resources. This is an interesting thing as far as what is another benefit of a BNG. I'll hit it on this point here, maybe didn't on the other slide, but once you break out your workload, your traffic to layer 3, you can classify it and you can determine, I can direct it to my apps where I want to now. We put in 3 servers for SEBA. I may have 1,000 subscribers on one SEBA site, and I may be well towards 16,000 on another, let's say. It's from experience, the workload of access will be driven by the number of subscribers, because you're collecting data about ONUs periodically, and that just is a constant workload. So to the extent that you have some cycles that you could engineer, possibly you could have some interesting apps running on some more lightly loaded access platforms. So there may be some additional opportunities here with respect to how to use scale within SEBA, how to look at it as available capacity as well, and how to improve the economics by converging with other things. And so many of these things are already happening in the community. I just want to tie them together as far as how they relate to this. But SEBA and COMAC convergence have an aspect of having some similar implementations of ASG and BBNG and a mobile packet gateway. Perhaps there could be some convergence of workloads in a solution, and for future investigation. I've mentioned, I call it value-added application hosting, where maybe some, if SEBA and COMAC are co-located, there are other opportunities to find some resources. For SEBA as a service, there are other, Sterlite is an example of an operator that's doing multi-tenancy, and so this is nothing new there, but it's a little bit of branding, and besides multiple operators, even within, if you're a large operator, you may have different types of of end users that may use the resources of the network differently, and so how they use just for access a consumer versus an enterprise, how much guaranteed bandwidth they have, and then again, how does that look in terms of if you could bring SEBA more together centrally and do what you need to do for what you want for running the access network, it just opens up some of the other things for centralizing an adjacent or shared cloud for lower latency applications again. The other thing about analytics, the other topic is analytics as a service. There's nothing new there. This is also something that's been talked about that the community is branding, but to use the SEBA cloud resources for enhanced analytics. So doing closed loop closer to where it happens for the access network. And in this case, we really are, I'm going to use examples of the infrastructure. Let's use some cycles to collect, present, to analyze, possibly even present some things happening with the cloud servers. Maybe that's feeding it to where you want that analytics to be done, so that it can be done offline, but it could just be collected. There's an area in the access network that, from experience, is when you want to think about your optics and how they degrade, and also there's an area for, I'm not taking any errors now, but my forward error correction is showing that it's increasing over time. So I want to analyze that, and I want to maybe set some flags. I threshold. These could feed possibly some thresholding to say, hey, I'm seeing something develop here. And these are things that don't that when you develop these features and receive them from vendors, they definitely can provide them, but the open source aspect of this allows you to write the code then off of what's available, and so extending SEBA for analytics. And this is a topic for the RD for the next RD version. So in any ideas there, these are just a few. So I'll go to the last slide, and I have provided links to the three open, the other related open community projects, Akraino, OCP, and ONAP for this topic. All right.
Thanks, Tom.
Sure.
Any question for Tom?
So, hello? Yeah. So the ONAP Kubernetes-based cloud region support is within the multi-cloud project, or it's separate?
It's called multi-cloud also in, yes, it's the multi-cloud service project in ONAP, yes.
Okay, the same project, but just, I see
Yes.
the name, so it's
Yes.
a new one.
This is actually would be a subset of it, the Kubernetes based. So I focused it on Kubernetes because that's native to SEBA.
Yeah, very good. Thanks.
Okay, thank you, Tom.
Thank you, Sean.
Our next